Hi and welcome to this session on rate equations. In the last lesson, we had a look at, I introduced rates of reaction to you. We had a look at the continuous monitoring methods we can use, and then once those are plotted onto a graph, how we can measure and calculate the rate of reaction from a concentration time graph. In this lesson, I'm going to introduce the rate constant to you. The rate equation, and the rate of reaction as well, depends on three main things. We've got the concentration of reactants, the temperature of the system, and whether there's a catalyst involved as well. Let's say I've got an equation as such. The rate equation for this particular experiment is going to be K, our rate constant, times the concentration of A, M, the concentration of B, N. So K is our rate constant. You'll come across the letter K quite a lot. It often does mean a constant. But what are M and N? You may not have heard of these before. So M and N, these are order numbers. So they're order of reaction with respect to A and B. That's how we phrase it, with respect to A and B, our two reactants. A top tip here, the orders of reaction, M and N, are nothing to do with the number of moles of the reactants. I know that we sometimes refer to moles as N in our calculations as shorthand, but it's nothing to do with it. These are order numbers. They must be worked out by an experiment. We cannot just work these out on paper. If the concentration of all of the reactants is equal to 1 mole per decimeter cubed, then the value of K is equal to the rate of reaction.